Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Python modules, Part 2, for the Class 11 students of Computer Science. Let's dive in and get started. In Python, we have worked with script mode in the previous videos, which provides the capability to retain our work for future usage. For working in script mode, we need to write a module or function in Python and save it in the file having .py extension. A Python module is written once and used or called as many times as required. Modules can be categorized into built-in modules and user-defined modules. Let's learn about the standard built-in Python modules. Some of these important modules are explicitly designed to encourage and enhance the portability of Python programs, such as Math module for mathematical functions, Random module for pseudo-random number generation, and Statistics module for calculating mathematical statistics of numeric data. Let's discuss about the Math module. The Math module in Python is a built-in module that provides various mathematical operations and functions. It allows you to perform complex mathematical calculations easily. To use the Math module, you need to import it into your Python script using the following line of code. Import math. This is the very first statement to be given. Let's discuss about the given function one by one. Python's built-in mathematical functions. Let's discuss about the two mathematical constants pi and Euler's number. In Python, you can access two commonly used mathematical constants, pi and Euler's number, through the Math module in the Python standard library. Pi is a well-known mathematical constant, which is defined as the ratio of the circumference to the diameter of a circle, and its value is 3.141592653589793. Look at example 1. To import this single object pi from the Math module, let's see the code. Line 1, import math. We are importing the Math module. In line 3 and 4, we are importing a single object pi from the Math module and storing in a variable pi underscore value and finally printed. Now, look at example 2. Alternatively, it can be done without prefixing the module name and writing the name of the object directly after keyword import. From math import pi. Print pi. The output will be the same as example 1. Similarly, another well-known mathematical constant defined in the Math module is e. It is called Euler's number, and it is a base of the natural logarithm. Its value is 2.71828182845945. Look at example 3. These constants can be directly called and used from Math module. Note that we should remember not to use module name with imported object. If imported through from module import command, because now the imported object is part of your program's environment. The math.ceil of x function in Python returns the smallest integer greater than or equal to the given number x. It rounds the number up to the nearest integer. Let's see these examples. In line 1, the import math statement imports the Math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.ceil function is called with the argument -25.17. This function returns the smallest integer greater than or equal to -25.17, which is -25 and is printed to the console. In line 4 and 5, the math.ceil function is called with the argument -200.12. The function returns the smallest integer greater than or equal to -200.12, which is -200 and is printed to the console. In line 6 and 7, the math.ceil function is called with the argument -200.72. The function returns the smallest integer greater than or equal to -200.72, which is -200 and is printed to the console. In line 8 and 9, in this last example, the math.ceil function is called with the argument 200. Since 200 is an integer, the math.ceil function simply returns the same integer value 200 and is printed to the console. The math.floor of x function in Python returns the largest integer less than or equal to the given number x. It rounds the number down to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.floor function is called with the argument -25.17. This function returns the largest integer less than or equal to -25.17, which is -26, and is printed to the console. In line 4 and 5, the math.floor function is called with the argument -200.12. The function returns the largest integer less than or equal to -200.12, which is -201, and is printed to the console. In line 6 and 7, the math.floor function is called with the argument -200.72. The function returns the largest integer less than or equal to -200.72, which is -201, and is printed to the console. In line 8 and 9, the math.floor function is called with the argument 200. Since 200 is an integer, this function simply returns the same integer value 200 and is printed to the console. The pow function in Python is used to calculate the power of a number. It takes two arguments, the base number and the exponent. It returns the output in floating point number. Syntax is pow of base, exponent. The pow function returns the result of raising the base to the power of the exponent. It is equivalent to using the exponentiation operator. Let's see some examples. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, this statement calculates 2 raised to the power of 2 using the pow function from the math module. The result is 4, and it is printed to the console. In line 3, this statement calculates 10 raised to the power of -2. The pow function supports both positive and negative exponents. In this case, 10 raised to the power of -2 is equal to 0.01 and is printed. In line 4, this statement calculates 4 raised to the power of 2, resulting in 16.0, and is printed to the console. In line 5, this statement calculates 5 raised to the power of 0. Any number raised to the power of 0 is always 1. Therefore, the result of this expression is 1, which is printed to the console. The fabs function in Python is a built-in function provided by the math module. It is used to return the absolute value, positive value, of the expression or number. It returns a floating point number, even if the argument is an integer. Now, look at this example. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, math.fabs of number returns the absolute value of the variable number, which is -25. The result is then printed, giving us the output 25.0. Let's see the difference between fabs and abs function. Data types. The fabs function is specifically designed to work with floating point numbers, while the abs function can handle both integers and floating point numbers. Module requirement. The fabs function is part of the math module, so you need to import the module using import math before you can use it. On the other hand, the abs function is a built-in function in Python, so you can use it without any imports. Return type. The fabs function always returns a floating point number, even if the input is an integer. In contrast, the abs function returns an integer if the input is an integer, and a floating point number if the input is a floating point number. The sqrt function in Python is used to calculate the square root of a number. This function accepts a number which is greater than 0, otherwise results in runtime error. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making all its functions and variables accessible in the current script. In line 2 and 3, we use the math.sqrt function to calculate the square root of 16. The output is 4.0. In line 4 and 5, we calculate the square root of 22 using math.sqrt of 22, and the output will be 4.69041575982343. In line 6 and 7, we calculate the square root of 22 using math.sqrt of 22, and then apply the round function to round the result to the nearest integer. The rounded value, which is 5, is printed on the console. In line 8 and 9, when trying to calculate the square root of a negative number, such as minus 22, an error occurs because the square root of a negative number is not defined in the real number system. This will result in a value error being raised. The log10 function in Python is used to calculate the logarithm base 10 of a number. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making its functions and variables accessible in the current script. In line 2 and 3, we calculate the logarithm base 10 of 100 using math log 10 of 100. The result, which is 2.0, is printed on the console. In line 4 and 5, we calculate the logarithm base 10 of 100.42 using math log 10 of 100.42, and the output is 2.0018202170383328, is printed on the console. In both cases, the math.log10 function takes the argument as the number for which you want to calculate the logarithm base 10. It returns a floating point number representing the logarithm base 10 of the given number. The cos function in Python is used to calculate the cosine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the cosine of different angles using the math.cos function and print the results. In line 2 and 3, we calculate the cosine of 0 radians, or 0 degrees, using math.cos of 0. The result will be 1.0, as the cosine of 0 degrees is 1. In line 4 and 5, we calculate the cosine of 30 degrees using math.cos of 30. The argument is in degrees, but the math.cos function expects the angle in radians. So, internally, the value is converted to radians. The result will be approximately 0.15425144988758405. In line 6 and 7, we calculate the cosine of minus 3 radians using math.cos of minus 3. The result will be approximately minus 0.989924966004454. Negative angles are allowed, and the math.cos function will calculate the cosine accordingly. In line 8 and 9, we calculate the cosine of pi radians using math.cos of math.pi. The result will be minus 1.0. The sine function in Python is used to calculate the sine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the sine of different angles using the math.sine function and print the results. In line 2 and 3, we calculate the sine of 0 radians, or 0 degrees, using math.sine of 0. The result will be 0.0, as the sine of 0 degrees is 0. In line 4 and 5, we calculate the sine of 30 degrees using math.sine of 30. The argument is in degrees, but the math.sine function expects the angle in radians. So, internally, the value is converted to radians. The result will be minus 0.98803162409286818. In line 6 and 7, we calculate the sine of minus 3 radians using math.sine of minus 3. The result will be approximately minus 0.141120008059867. Negative angles are allowed, and the math.sine function will calculate the sine accordingly. The tan function in Python is used to calculate the tangent of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the tangent of different angles using the math.tan function and print the results. In line 2 and 3, we calculate the tangent of 0 radians, or 0 degrees, using math.tan of 0. The result will be 0.0, as the tangent of 0 degrees is 0. In line 4 and 5, we calculate the tangent of 3 radians using math.tan of 3. The result will be minus 0.14254654307427778. In line 6 and 7, we calculate the tangent of minus 3 radians using math.tan of minus 3. The result will be approximately 0.14254654307427778. The help function in Python is used to access the built-in documentation, docstring, of a particular object, module, function, or class. It displays information about the object and how to use it. Now, look at this example. When you run this code, the documentation for the math.tan function will be displayed in the console or interactive shell. It will provide information about the function's purpose, parameters, and usage. Note that the help function returns the documentation as a string, so you need to use print to display it. Now, let's see about the random module. The random module is like a magical tool that helps us create randomness and surprises in our programs. Generating random numbers. Just like rolling a dice and getting a random number between 1 and 6, the random module helps us generate random numbers in our programs. We can use these numbers to make computer games more exciting or make decisions in our programs. Picking random things. Imagine you have a jar filled with different colored candies. The random module can help us pick a random candy from the jar. We can use this to create surprises in our programs, like picking a random character in a game or a random question in a quiz. Shuffling things. Think of a deck of playing cards. The random module can help us shuffle the cards so that they are in a random order. We can use this to create random sequences or mix up things in our programs. Pseudo-random numbers on lottery scratch cards. ReCAPTCHA, like in login forms, use a random number generator to define which image is to be shown to the user. In Python, random numbers are not enabled implicitly. Therefore, we need to invoke random module or random code library explicitly in order to generate random numbers. The first statement to be given in a program for generating random numbers is import random. Let's see the various functions associated with the random module. The randrange function is a part of the random module in Python. It allows us to generate a random number from a specified range. This method generates an integer between its lower and upper arguments. By default, the lower argument is 0 and upper argument is range -1. The syntax is random.randrange of start, stop, step. The randrange function takes in 3 parameters. Start, optional. It specifies the starting point of the range, inclusive. If not provided, it defaults to 0. Next parameter is stop. It specifies the ending point of the range, exclusive. The function will generate random numbers up to, but not including, this value. Step, optional. It specifies the step size or interval between numbers in the range. If not provided, it defaults to 1. The start, stop, and step values can be integers. Let's see an example. In line 1, the import random is used to bring the random module into our code. By importing the random module, we gain access to various functions and capabilities that allow us to work with random numbers and randomness in our program. In line 4, we are using the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 0, specifies the starting point of the range, inclusive. In this case, we want our range to start at 0. The second parameter, 10, specifies the ending point of the range, exclusive. We want our range to go up to, but not include, 10. The third parameter, 2, is the step size or interval between numbers. It indicates that we want to generate only even numbers within the range, as we are incrementing by 2 at each step. The randRange function will then produce a random even number between 0 and 10, exclusive, based on the specified range and step size. This random even number is assigned to the variable even_number. Finally, we use the print function to display the value stored in the even_number variable. The output will be the randomly generated even number between 0 and 10. Here, you can see the output displayed each time a random number, for the first code 4, for the second code 8, and for the third code 6. Let's see another example. In line 2, the line import random imports the random module into our code. This module provides functions that allow us to work with random numbers, make random selections, and more. In line 3, we define a list called subjects that contains 4 different subjects as elements. Each subject is represented by a string. In line 4 and 5, we use the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 2, specifies the ending point of the range, exclusive. Since we provide only one parameter, the starting point is assumed to be 0. The randRange function will then produce a random number between 0 and 2, exclusive. It could be either 0 or 1. The random number generated by randRange is assigned to the variable ran_index. This number will serve as the index to select a random subject from the subjects list. Finally, we use the print function to display the subject at the randomly chosen index in the subjects list. Since the ran_index variable holds a random number between 0 and 2, it will randomly select one of the subjects from the list. So, the overall code imports the random module, creates a list of subjects, generates a random index using randRange, and then prints the subject corresponding to the randomly chosen index. You can see the output that, each time the code is run, a different subject will be printed, adding an element of randomness to the program. The random function generates a random decimal number between 0 and 1. This function can be used to generate random floating point value in the range 0.1, 1.0. It takes no parameters and returns values uniformly distributed between 0 and 1, including 0, but excluding 1. Let's see some examples. In this code, each time random function generates a different number. Program to calculate the sum of the digits of a random 3-digit number. This code generates a random number n between 100 and 1000, and then separates the digits of n to calculate the sum of its individual digits. Look at line 4. The random function generates a random fractional number from 0 to 1. When a random number generated using random function gets multiplied by 900, a random number is obtained from 0 to 899. When we add 100 to it, we get a number from 100 to 999. Line 7 and 8 converts the random number to an integer. Line 11, 12, and 13 extracts the individual digits from the random number. Line 16 and 17 calculates the sum of individual digits. When you run this code, it will output two numbers. The first number, n, is a random integer between 100 and 1000. The second number is the sum of the individual digits of n, that is, a plus b plus c. In this case, n is 547, and the sum of its digits, 5, 4, and 7, is 16. Next time when you run the code, n is 670, and the sum of its digits, 6, 7, and 0, is 13. The randint function generates a random integer between a specified range. It is part of the random module in Python. Now, look at this example. In this code, randint of 1, 10 generates a random integer between 1 and 10, including both endpoints. Each time you run the code, it will output a different random number within the specified range. For example, the output could be 2 and the next time, it could be 3 and so on. Let's learn some more functions of the random module. The uniform function is another function provided by the random module in Python. It generates a random floating point number between two specified values. The syntax is random.uniform of x, y. Now, look at this example. In this code, uniform of 0, 1 generates a random floating point number between 0 and 1. The range is inclusive of 0 but exclusive of 1. Each time you run the code, it will output a different random number within the specified range. You can see the output below. The choice function is another useful function provided by the random module in Python. It allows you to randomly select an element from a sequence, such as a list or a string. The syntax is random.choice of sequence. Let's see an example. You can also use the choice function with strings. In this case, choice of my_string selects a random character from the my_string string. The output could be any character from the string, such as R, next time it could be L, and so on. The shuffle function is another useful function provided by the random module in Python. It allows you to randomly shuffle the elements of a sequence, such as a list. The syntax is shuffle of list. Let's see an example. In this code, shuffle of my_list shuffles the elements of the my_list list in place, meaning it modifies the list directly. Each time you run the code, it will output a different order of the elements in the list. For example, the output could be list of elements 4, 3, 5, 1, 2, and next time it could be list of elements 3, 4, 2, 1, 5. The shuffle function is particularly useful when you want to randomize the order of a list or when you need to randomly permute a sequence of elements. It can be handy for implementing algorithms like shuffling a deck of cards, randomizing quiz questions, or generating random permutations. In Python, the statistics module is a built-in module that provides functions for mathematical statistics of numeric data, that is real-valued data. The statistics module implements many common statistical formulas for efficient calculations using Python's various numerical types, that is int, float, decimal, and fractions. Before using the functions of this module, it is required to be imported first using the statement, import statistics. Let's see the popular statistical functions which are defined in this module. Mean, median, and mode. The mean function calculates the arithmetic mean of the numbers in a list. What do you mean by arithmetic mean? It is calculated by summing up all the values in a dataset and then dividing that sum by the total number of values in the dataset. That is finding the average. Let's look at the Python code. The first line imports the statistics module in Python. The statistics module is a built-in module in Python that provides functions for mathematical statistics of numeric data, including mean, median, mode, standard deviation, and more. Next, we define a sample list of numbers named data. This list contains 5 numbers, 10, 20, 30, 40, and 50. Next, we calculate the mean of the numbers in the data list using the statistics.mean function. The mean function takes a list of numbers as input and returns the arithmetic mean, average, of those numbers. Finally, we print the result, which is the mean of the numbers in the data list. The mean_value variable holds the result of the statistics.mean function calculation, and it's printed along with a descriptive message. So, now look at the output. mean of the numbers is 30. That is 10 plus 20 plus 30 plus 40 plus 50 is equal to 150. Then 150 is divided by the number of count, that is 5, and hence the output is 30. Next statistics module is the median function. The median function is a measure of central tendency that represents the middle value of a sorted dataset. To find the median, arrange the data in ascending order. If the dataset has an odd number of values, the median is the middle value. If the dataset has an even number of values, the median is the average of the two middle values. Let's see an example. Let's calculate both the median for the odd and even dataset. For the odd dataset, 20, 5, 10, 25, 15. Sort the data, 5, 10, 15, 20, 25. Since the dataset has an odd number of values, 5, the median is the middle value, which is 15. For the even dataset, 20, 5, 10, 25. Sort the data, 5, 10, 20, 25. There is no single middle value, so the median is the average of the two middle values, 10 plus 20, divided by 2 is equal to 15. Let's see the Python code. The first line imports the statistics module in Python. The statistics module provides functions for calculating mathematical statistics of numeric data, including functions for mean, median, mode, standard deviation, and more. In the first section, you define an odd dataset data_odd containing the numbers 20, 5, 10, 25, 15. Then, you use the statistics.median function to calculate the median of this dataset. The result is stored in the variable median_odd. Finally, you print the calculated median. In the second section, you define an even dataset data_even containing the numbers 20, 5, 10, 25. You calculate the median of this dataset using the statistics.median function and store the result in the variable median_even. Finally, you print the calculated median. Let's look at the output. Median of odd dataset is 15 and median of even dataset is 15. In Python, the mode function from the statistics module is used to find the mode of a dataset. The mode is the value that appears most frequently in a dataset. The mode is a statistical measure that represents the most frequently occurring value in a dataset. In other words, it's the value that appears with the highest frequency. Example, consider the dataset 2, 3, 3, 5, 5, 5, 7, 7, 7, 7. In this dataset, 2 appears once, 3 appears twice, 5 appears 3 times, 7 appears 4 times. Among these values, 7 occurs most frequently, 4 times, making it the mode of the dataset. Let's see the Python code. The first line imports the statistics module, which provides functions for calculating mathematical statistics of numeric data, including functions for mean, median, mode, standard deviation, and more. Next, you define an example dataset named data. It's a list containing the numbers 2, 3, 3, 5, 5, 5, 7, 7, 7, 7. Next, you use the statistics.mode function to calculate the mode of the data list. This function returns the value that appears most frequently in the dataset. If there are multiple modes, that is, multiple values with the same highest frequency, it returns the smallest one. If there's no repeated value, it raises a statistics error. Finally, you print the calculated mode value using the print function. The message mode of the dataset is concatenated with the value of mode_value and printed to the console. When you run this code, it will output mode of the dataset 7. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos. You can check the link in the description box below.